Let's work through this geometry problem carefully. We are given a rectangle, A, B, C, D, where side AB is 12 units and side BC is 10 units. Inside the rectangle, two congruent semicircles are drawn, and they intersect at points P and Q. Our goal is to find the length of segment PQ. The first thing we need to do is find the radius of the semicircles. Notice that AB is the diameter of the semicircle, and its length is 12. Since the radius is always half of the diameter, we get radius equals 12 divided by 2, which gives us 6. So the distance from the center O to any point on the semicircle is 6 units. Now let's focus on segment PQ. Draw the midpoint M of PQ. There is an important circle theorem that says the perpendicular from the center of a circle to a chord bisects the chord. In other words, when the line from O meets chord PQ at right angles, it cuts the chord into two equal parts. That means PM equals MQ. Keep that fact in mind because it will help us find the entire length later. Now, let's determine the distance OM. The rectangle has width BC equal to 10 units. Because the figure is perfectly symmetric, the chord PQ lies exactly halfway across the rectangle. Therefore, OM is half of 10, which is 5 units. Now, look carefully at right triangle OMP. We know OP is a radius, so OP equals 6. We also know OM equals 5. The only unknown side is PM. Since this is a right triangle, we can apply the Pythagorean theorem, which states that the square of the hypotenuse equals the sum of the squares of the other two sides. So, we write OP squared equals OM squared plus PM squared. Substituting the known values gives 6 squared equals 5 squared plus PM squared. 6 squared is 36, and 5 squared is 25, so we get 36 equals 25 plus PM squared. Next, subtract 25 from both sides. That gives us PM squared equals 11. Taking the square root of both sides, we obtain PM equals square root of 11. Remember what we established earlier. Since M is the midpoint of PQ, the entire chord is made up of two equal pieces. Therefore, PQ equals 2 multiplied by square root of 11. And that gives us the final answer. PQ equals 2 square root of 11 units. Notice how the whole problem comes down to identifying a right triangle and applying the Pythagorean theorem correctly. If you found this solution helpful, be sure to like the video, subscribe to the channel, and leave a comment with your answer before watching the solution. It really helps the channel and lets me know which kinds of geometry problems you'd like to see next.